Okay guys, welcome back. Today I'm going to be talking about linear functions. So the typical form you see of a linear function is what's called slope-intercept form, and that's probably, if you're experienced with linear functions, that's most likely what you're used to saying, and that is the form of y is equal to mx plus b, where x is your input, y is your output, m is your slope or rate of change, and b is your y-intercept. So I'm going to kind of dissect this equation and go through what each little part means in addition to what I just said. So you most likely know input and output of the x and y, but you might not know about the slope or the y-intercept as much. So I'm just going to go over those a little bit. So I mentioned the slope. So whoops. And I broke something apparently. Give me a second. Okay, I stopped breaking everything. Everything is fine now. Okay, so as I was saying, the slope or the rate of change is exactly what it sounds like. So what it is it's the change in the y direction. So the change in the y direction over the change in the x direction. So you might see me using these little triangle things right here. So that's called delta. And so what a delta is essentially saying is it's saying a change in. So the way that this would be formally written out would be y2 minus y1 over x2 minus x1. That's the long way of writing it. That's just the abbreviated way of writing it. So what that is, I'm sorry. So that's just kind of the gist of rate of change of how to find it. So let's look at a little bit of an example. So let's say we have a graph like this, and the line is going like that. And let's say right here, that's 100. Then we have up here 200 and 300. And this is 1, 2, 3. So this is hours, this is kilometers. So we have time and distance. So as you can see, we have 100 kilometers in an hour, 200 kilometers in 2 hours. So let's use this formula to try to figure out the rate of change of this one, even though that's a little bit obvious if you somewhat know what you're doing. So let's take the second point, 200 kilometers, and subtract it from this point, which was 100 kilometers. And as you can see right now, I'm taking from the x-axis right now because the numerator will always be from the y-axis. And then let's look at the x-axis. So with 200, that's at 2 hours. So we're going to use 2. And then 100 is 1. So you get 100 over 1, which is 100 kilometers per hour. And so that is the rate of change of this graph right here. And so you can do that if you're ever given a graph, or in the case where you're just given 2 points and then you have to find the speed of it or something. Like, let's say you're given a race. Let me take a moment to restart this. Okay, so that race example now. So let's say we have someone running a race, and it is a 1,000 meter race. So 0, 1,000. But let's say 15 minutes in, a man stops for water 200 meters in, and then it takes him another 30 minutes to finish the rest of the race. How long did it, or how fast was he running on it? If he was running at a constant speed, how fast was he running from the 200 meter mark to the end of the race? So the way that you would look at this, so if this was 15 minutes, so you would take the final distance, which would be 1,000, subtract the distance that we're going to start measuring from, which is 200, and then you're going to take the initial time, or the final time, which is 15 minutes plus 30 minutes, which is 45 minutes. And then you're going to subtract the initial time, which was 15 minutes. So you have 800 over 30. So you have 80 thirds meters per minute. And I know that's not the cleanest number, but I was just making it up on the fly just to give you a quick example of how else rate of change could be applied to this. So I think I've sufficiently gone over that. So maybe it is about time to go into a different form, now we're going to talk about intercepts now. So let's take a minute and talk about that variable b in y equals mx plus b. So b, like I said before, is the y-intercept. And so what that means is on a graph, let's say we have a graph and on a linear line, and it's a graph of a linear function, and it goes like this. That point where the graph intersects this y-axis, that is the y-intercept. So that little buddy right there. So the way that you would find this if you were given the function, so let's say we have a function of y is equal to 2x plus 3. The way that you would find the y-intercept is plugging in 0 for x. So you plug in 0 and you get y is equal to 0 plus 3. So y is equal to 3. It's essentially as easy as that. And then if you were going to find the x-intercept, which isn't important for finding, or for the equation of a linear line, but if you ever wanted to find it or needed to find it, it would be where the graph intersects on the x-axis, and you would just do the same thing as if you would plug in 0 for y. So you get 2x plus 3, subtract 3 from both sides, you get negative 3 is equal to 2x. So negative 3 halves is the x-intercept. Now we are going to get to the part of the video that I was getting ahead of myself a little bit with before, and that is transferring slope-intercept form into a different form of writing a linear equation. So this form is going to be called standard form. And so standard form looks like this. ax plus by equals c, where a, b, and c are all integers, and they have no common factors of each other. And a specifically must not be negative. So let's look at an example of transferring slope-intercept form into standard form. So let's say we have the slope-intercept equation of y equals 5x minus 7. This one's pretty simple. All that you have to do is you subtract 5x from both sides. So you get negative 5x plus y is equal to negative 7. So let's run through our little checklist here now. They are all integers because they are all integers. They have no common factors besides 1. But then we run into a problem on our last little check here, because a here, that is the coefficient in front of the x, is negative. So what we have to do is we have to multiply by -1, so we get 5x minus y is equal to 7. So that would be our equation in standard form. So let's try another one now. So let's say we have y is equal to 7x plus 3/2. So now we have to start like we did before. We have to subtract 7x from both sides. So now we have 7x plus y is equal to 3/2. So now we run through our little checklist again. So we do not have all in integers because this 3/2 right here is obviously not an integer, it's a fraction. So we have to multiply by 2 throughout the equation. So now we have -14x plus 2y is equal to 3. So now we have all integers. We have no common factors other than 1. But now we have this negative sign in front of our a, so we have to make that positive by multiplying through a -1. So now we have 14x minus 2y minus 3 equals -3. So that would be our standard form of that equation. Okay,